Hello, ladies and gentlemen, and welcome to our last lesson in distant learning. So, this will be your last lesson for this semester. Congratulations. 8.3, the quadratic relation. Y equals ax squared plus c. For a quadratic relation in this form, a x squared plus c, we can tell a few things about its maximum, its minimum, and where it's going to occur. So the quadratic relation in this form, the maximum or minimum of value will occur at C. This value here, which is going to be the vertex. Now, we know that a quadratic function, when it's graphed, looks like a U up or down. So what's happening is we're going to be talking about a quadratic. It's going to be looking something like either this, in which case we're going to have a maximum, or it's going to open up, in which case we're going to have a minimum. And this value, when it's in this form, the C value is going to give you that maximum or minimum value. It's going to be at its vertex, and oddly enough, when it's in this form, not when there's a bx involved, but when it's just an ax squared plus a c, this vertex is also going to be on the y-intercept. Okay, so number one, find the maximum or minimum of each relation. Well, what we know from looking at this is y equals ax squared plus c. So in this case, a equals 1, positive 1, and c equals negative 9. Since the a is positive, it opens up. And if it opens up, therefore it's going to have a minimum. That minimum value is going to be at c equals negative 9. So it's going to have a vertex at 0, negative 9, and that's going to be its lowest point. So this little parabola, if I had to make a rough sketch of it, just knowing what I know here, I know that it would be at 0, negative 9, and it would open up. That's how much I know about this based on the fact that it's x squared minus 9. Okay, so let's do another one. Just grabbing a different color here. In this case, a equals negative 2 and b equals positive 32. So a is less than 0. So therefore it opens down. If it's going to open down, then there's going to be a maximum value. And that maximum value is going to occur at 0, 32. So this particular one that I'm drawing is going to look like this. 0, 32, and it opens down. And it's going to continue to go down and down. It's going to cross the x-axis and all that good stuff. Okay, now again, this is new and I'm teaching you something. So you just have to learn this, that when you have something in this form, y equals ax squared plus c, we can get this information from it. So looking at this one, you notice that the a value is 3 and your b value, well, there is no b value, right? Because there's no x value, is 0. But in this case, the c is also 0. So with this c value being 0, that means that it's going to have a vertex at 0, 0. Remember how it was 32 and it went in here, and it was negative 9, so it went in here? Well, this is 0, so it goes in here. And since a is greater than 0, it opens up, which means that you have a minimum value. Which means that the graph of this will look something like, now it has a vertex of 0, 0, so it looks like that. Very cool, very cool. All right, example 2. Find the zeros of x squared minus 9. Well, we learned a little bit about this last day. We learned that if we're going to find the zeros of a function, what we're looking for is to put it into factored form. That's what this says over here. So we got to remember that we need to put this in factored form. Now, last day we learned how to factor trinomials. This is not a trinomial. Okay? It's not a trinomial, so we're not going to do trinomial factoring. This is a different type of factoring, one that we learned before, and that was difference of squares factoring. And what that was, if you remember, it was when you have two things that are squared being subtracted. That's why it's a difference of squares. That could be factored into the first term minus the second term times the first term plus the second term. And that's called a difference of squares factoring. Now, we learned that a little while ago, but what we have now is y equals x squared minus 9. This is a difference of squares because it is 3 squared equals 9. So this can be factored into x minus 3 and x plus 3. Now, when we're looking for the zeros, we're looking for when it's going to cross the x-axis, when the y value is going to be 0. So for zeros, you're going to set y equal to 0, and you get 0 equals x minus 3 and x plus 3. Now again, we've looked at this before, and we can either say, okay, for two things to multiply to give 0, either the first one 0 or the second one 0. In which case, x equals 3, we're isolating for x, and x equals negative 3. Now we can do that, or we can know that when it's in the factored form, the zeros can be read from here. So it's going to be positive 3 and negative 3. And go back to the section where we did this, and you'll see why. And it's because the formula has negatives here. So this r value, if I see the negative, the r is actually positive. And since there's a negative here, if I see a positive, then that s value must have been a negative to make this negative go to positive. All right, so that's the end of example 2. I'll pause here and then we'll keep going.